Hey guys, Mr. B here, and in this video we're going to be going over the chapter 4.1 notes on the structure of the atom and just learning about the history of the atom and where it came from. So in this section we're going to be looking at history of the atom, where the idea of atoms came from, and some of the early theories set down about atoms, and kind of that leads us into talking more about the atom in further chapters. All right, so to start off, let's just talk about what an atom is. Okay, atoms are the smallest particle of any element that still retains chemical properties. So it's the smallest piece of anything you can have that still will behave like that thing. It's not the smallest piece or particle that we know of, because you can break atoms into smaller pieces like protons and electrons and neutrons, but it's the smallest piece of matter that still has properties that identify it or make it different from something else. Now, the idea of atoms have been around for a long time. So the very first philosopher who came up with the idea of the atom was called Democritus. Now, he wasn't a scientist, he was a philosopher. So philosopher is someone who just kind of reasons about things or uses logic to kind of explain the world around us. And so his idea was that, if you took a piece of material, let's say like an iron bar, and you cut it in half, then you took that half and you cut that one in half. And then you took that piece and you cut that in half. And you just kept on doing this over and over. Eventually, you're going to get to the point where you can't cut it in half anymore, right? You're going to get the smallest piece of that material that you can have, and it can't get any smaller. And so he used the Greek word atomos to describe this, which means uncuttable. And that's where the word atom comes from. And so his idea was that all matter is made of atoms, or small pieces of that material that can't be cut, and you take a lot of them and you put them together, and that gives you bigger pieces. And so these atoms are indivisible, so they're not cuttable, and they're indestructible, so you can't destroy them. Okay. Now, this is, of course, a really good idea, and we certainly know that nowadays atoms do exist, but at the time, he didn't have any kind of experimental evidence to support this. He just kind of thought about it in his head and goes, yeah, this makes sense, and so people had to take his word for it, which, of course, at the time they didn't. So even though this sort of started the idea of atoms, it wasn't the end of and be all of atoms, because they didn't really have a whole lot of info on them. So it was about 2,000 years later when this idea was expanded upon by an English chemist and school teacher named John Dalton. And John Dalton basically wanted to expand on Democritus' idea of atoms, but he wanted to do so with experimental evidence. That way people actually believed him, and he could prove that atoms existed and that they worked the way they did. So John Dalton is oftentimes in chemistry referred to as the father of the atom, and he developed the first atomic theory that described how atoms work. So there are 4 parts to his theory. The first part basically said that all elements are composed of tiny indivisible particles called atoms. This is no different than what Democritus basically said. So no new information here. Okay, and we know that all elements are composed of atoms. Now, there was certainly a part of this that was incorrect, and that is that atoms are divisible. Okay, meaning you can divide them into smaller pieces. At the time, they didn't know that, because they didn't know that protons and electrons and neutrons exist. But either way, so this is the first part of his atomic theory, and again, kind of still stands true today. All elements are composed of tiny particles called atoms. They are divisible, but that's beside the point. The second part of his theory basically said that all atoms of one element are identical, and that atoms of any one element are going to be different from atoms of any other element. This we also know, again, to this day, is true. Atoms of one element are all going to look the same, and they will look different from atoms of another element. And they look the same for the most part. Okay, we're going to learn about things later called isotopes, which are actually variations on atoms. But either way, for the most part, this is also true. Okay, and it still holds till today. So if atoms of element A are maybe blue and small, and atoms of element B are maybe big and red, or something like that. All right, the third part to his atomic theory was that atoms of different elements can physically mix together, or they can chemically combine in whole number ratios to form compounds. So physically mixing means, you take them and you just kind of mix them together like in a bowl of cereal, right? And they all just kind of mix together, but they're not connected. So it means that you could just separate them apart if you could somehow, see them and pull them apart. And that we know is true. But also they can chemically combine to make compounds. So that means that they would be joined together and they'd make a new material. And they do so, though, in whole number ratios. So basically what that means is that you can't take half of one atom and 3/4 of another atom and put them together. You got to take one whole atom and one whole atom, or two whole atoms and one whole atom, and they combine in whole numbers, which we know that that is also true to this day, and that still holds. The last portion of his atomic theory basically says that when chemical reactions occur or chemical changes happen, atoms either are separated, okay, so they come apart, they're joined together, or they rearrange. So maybe they're already joined, but then they break apart, and this one goes in pairs with a different atom, and this one goes in pairs with a different atom. That also we know is true, okay? So that during chemical reactions, that is what is happening. Atoms are either separating, joining, or recombining. And atoms of one element are never changed into atoms of another element in a chemical reaction. We also know that that is true. So basically what this means is that alchemy is not a thing. And alchemy, if you don't know what that is, was the art of transmuting one material into another. So that was thinking you could take like copper and transmute it, turn it into gold. That can't happen in a chemical reaction. Okay, even if something looks like it's changing into something else, you're not changing from one element into another element, okay? That can occur in a nuclear reaction, but not a chemical reaction. And we're not going to get into nuclear reactions. So for the most part, this basically disproved the idea of alchemy and what alchemy said. All right, so that is John Dalton's atomic theory. And for the most part, that's most of the information for this chapter. There's one little tiny portion here at the end, and that is just talking about what instruments do we have to show that atoms do exist and that we know that they exist. So we don't have any instruments that can actually take a picture of an atom with enough resolution to actually see all the details of what an atom looks like. We do have tools that can see individual atoms, though they're fuzzy, okay? But it's still pretty good because atoms are very, very small. So even seeing an individual atom, even if it's fuzzy, is still better than not seeing them at all, which it took us a long time even to create those instruments. So even though atoms are very small, we do have an instrument that can see them. It's called a scanning tunneling microscope. It's not like a microscope that you're used to where, you know, it's got an eyepiece and you look into it and it magnifies a little slide and you see it. Okay, it's not like that kind of microscope. A scanning tunneling microscope is basically a giant machine, and it has a really, really pointed tip. So think of a really long needle that goes to a tip that at the very tip of it is only one atom wide. So it's super, super pointy, basically. And what they do is they can bring this tip down to the surface of a material, and they can run an electric current through it, and they can pull individual atoms out or up out of the surface of the material. So they're not pulling the atoms out like fully, but they're pulling them up. And so what that does is it lets us actually see individual atoms because we can move them around with this microscope and create images. Now, the images that we're creating are usually generated by a computer, so they're not an image like, you know, you took a picture with a camera and you can look at it, because again, atoms are really small, and you would need a camera that has really good resolution and like 1,000,000 pixels in order to see an atom, which unfortunately our cameras are not that good. So we do create images using a computer, but either way, it's still, again, possible to see individual atoms, even if it's a computer-generated image and they're fuzzy, which is better than nothing. So, yeah, so that's basically it for this section. Again, the main takeaways are the two scientists that came up with most of the ideas of atoms, John Dalton's atomic theory and what it says, and of course, Democritus in the idea of the word atom and where it originated from. So, all right, guys, that's it for this section. I'm Mr. B. Thanks for watching, and I'll see you in the next one. Bye.